Hi, welcome to this quick recording on how to collect data for the density lab. I have the lab document open right here. At the top, it gives you the website where the Gizmos program is. That's where we're going to be doing the lab and collecting our data. You would click on this link here. Once you're there, you're going to have to log in with your username and password that you've created. If you don't know what it is, if you forgot, just send me an email or let me know in class and I could look it up for you. After you log in, you should see a bar that looks like this. It says Density Lab. You're going to launch the lesson. So you click that rocket ship. Once you're in there, I'm going to scroll down a little bit. You're going to use the program to collect this data. The recording I'm doing right now is going to be pasted right here in the lab document so that you can use it if you need to review on how to collect the data. So this first object here, object 5, I've done for you so you can use it as an example, and I'm going to go over into the program and show you how I've collected that data. Keep in mind as well that the density of water, we're going to need that to fill in the last column. The density of water is 1 grams per milliliter, so we're going to take a look at that as well. All right, I'm going to go over into the program. I'm going to pull up the website. And you could see here, once you're in the density lab, we have a whole bunch of objects. So we're not going to do all of the objects. I've chosen a couple for you to use. If you want to do more, you can, but you only have to do the ones that are listed in the data table. The one I'm going to do is object 5. And so I'm going to grab it. And we want to find the density. So we need to get mass and volume, right? So I'm going to put it on the scale. The scale says 3.9 grams. I'm going to put it in my data table. And again, we want to pay particular attention to significant digits. That's the point of the lab, or one of the points of the lab is to practice significant digits. And so when you're reading off of the scale, you write all of them down. So that's as accurate as it is. There's 2 significant digits there, so I would write down 3.9 grams. Then I'm going to take this object and put it into the graduated cylinder. Right now, the graduated cylinder is at 400 milliliters, so they're going to read the cylinder for you, which is why in the practice questions at the bottom of the lab document, I put in some for you to read because this program's not letting us practice that. But anyway, the starting volume is 400. I'm going to go ahead and put the object into the graduated cylinder. And it's telling me that my ending volume is 403.5 milliliters. And so to get my volume that I need to use to calculate my density, I subtract these 2 numbers. So the amount of volume that the liquid rises in your graduated cylinder tells you the volume of that object, right? So I take 400 minus 403.5, I get 3.5 milliliters. So the volume of object 5 is 3.5 milliliters. I'm going to now take my object and I'm going to put it over here into this beaker of water. I believe it's water, yes. Up here, they're telling me the density of water is 1.5, or they're telling me the density of this liquid is 1.0, I should say. So I guess they're allowing us to change the density, but we want to keep it at density of water, which is 1, so I'm going to leave it there. So now I'm going to take this object and I'm going to put it over into the beaker. And you can see that it's sinking to the bottom. So if we know the density of water is 1, and this object is sinking to the bottom and it's not floating, then the density of this object must be greater than 1. And so when we calculate it on our data table, hopefully we get a value that's greater than 1. And that's it. Once you're done, you can take the object and put it back on the shelf and then choose the next object from the data table to do. So let me go back over into the lab document and share with you the data. So this is the data we just collected for object 5, the mass, the initial volume, so that's where you start, the starting volume, the final volume, and again, you want to subtract those 2 numbers to get the object's volume. And now we want to calculate density. So density is mass per volume. You're going to take 3.9 grams divided by 3.5 grams, and you get an answer. Right? So I got 1.1, again, paying particular attention to my significant digits. The value here with the lowest amount of significant digits is 2, right? 3.9 has 2 significant digits. This one has 4. This one has 4. So we want our final answer to only have 2. So I have this 1.1 as my 2 significant digits for density. Then finally, over here in the last column, it's saying, is the object's density greater than that of water? Yes. And that's why it's sunk to the bottom of the container. The density of water is 1, and the density of this object is 1.0. So because it is greater than 1, then we expect that object to sink, and it did. Right? So all you have to do now is go back into the lab program and do objects 1, 4, 8, and let me just double check that. Oh, it's off the page. I was thought there was a letter in there, and I'm just going to have to fix this and pull it up a little bit so the data table is not off the page. I apologize. So you want to go back into the program and do the remaining objects in the data table. So 1, 4, 8, 10, and letter B. And when you're done, you can move to the next part. If you have any questions, please let me know.